constantly produce a lot of data, for example via social media, public transport, and GPS. But it goes way beyond that. Daily, we upload 55 million pictures, 340 million tweets, and 1 billion documents. In total, we produce 2.5 quintillion bytes a day. That's a lot of zeros. It's ridiculous. We call this big data. But what's actually more important is what you can do with it. To process big data, you don't need huge computers. People work with the cloud, an endless network of normal servers, and powerful algorithms. This way, they can analyze over 1 million pieces of data in minutes. And the result? Well, for example, video streaming website Netflix analyzed the big data of their viewers, like popular shows and watching patterns. This way, they produced a successful series with the perfect combination of actors, directors, and storyline. Right now, the big data of traffic is being analyzed to develop a car that can drive completely accident-free all by itself. And in the future, we can even use the big data of DNA to determine the perfect treatment. This way, curing genetic diseases like cancer would become much easier. And that's just the start.
Welcome to our demonstration on how to deploy a Hadoop cluster with vSphere Big Data Extensions, also known as BDE. vSphere Big Data Extensions is available at no extra cost with vSphere Enterprise and Enterprise Plus licenses. One can deploy a Hadoop cluster with a few mouse clicks using vSphere BDE. In this demo, we will create a small Hadoop cluster using vSphere Big Data Extensions. Note that in this environment, Big Data Extensions has already been installed on the vCenter server. Begin by logging into the vCenter web client and go to Big Data Extensions. Select Big Data Clusters and click on the Add Cluster icon to create a new Hadoop cluster. Assign a name to the cluster and select the distribution type. Apache is chosen as the distribution for this cluster. Then choose the type of cluster for deployment. There are multiple options available. We choose the basic Hadoop cluster for this demonstration. You can customize the number of nodes in the node groups and their sizing. You can choose to have a small, medium, or large node group, or you can customize the node group for your environment. Each node group has multiple virtual machines, which play different Hadoop functional roles, such as data node and job tracker. We will select small configuration and customize the number of worker nodes to 2. We will also customize the storage size for this demo. There are also options available for the Hadoop topology and the network. We retain the default selection of host as rack that will treat the vSphere host as a rack from a Hadoop topology standpoint. This ensures that replica copies are stored in virtual machines on separate physical hosts. Then under Resources, select the resource pool to be used by this Hadoop cluster and click OK. The deployment of the new Hadoop cluster begins. Note that the deployment may take several minutes. Within the cluster, 5 virtual machines will be deployed, as specified in the Hadoop template. BDE provides the capability to add multiple Hadoop distributions from different vendors. Once the cluster is deployed, we can see that the 5 new virtual machines are running and are available for Hadoop computations.
The Blue Data Epic software platform eliminates deployment complexity by virtualizing your infrastructure using Docker containers. The platform has 3 key components. Elastic Plane enables multiple big data clusters in minutes. With data taps, you can start analysis without moving data. I/O Boost enables bare metal performance with the power of Docker containers and caching. Blue Data software simplifies and democratizes your on-premise big data infrastructure. You can consolidate your big data infrastructure and view usage by different business groups or tenants. Pool the compute and memory from a set of hosts, physical or virtual. Instead of rigid physical servers, lightweight Docker containers power your big data cluster nodes, so you are up and running at a fraction of the cost and time. Multi-tenancy is a first-class concept in Blue Data. You can create multiple tenants. You can configure granular resource quotas for each tenant, so they have dedicated resources to meet their service levels. You get ready to run images of the latest versions of Hadoop and Spark. Get going starting in minutes versus the many months it takes currently. You also get images of a diverse set of ISV partner application products that accelerates time to analytics. Your end users, whether they are data scientists or big data administrators, get self-service, secure access to big data infrastructure. The infrastructure team can enable self-service for their end users while maintaining security and control. Unique with Blue Data is the ability to create a logical data lake across multiple storage sources. Start your analysis without moving terabytes of data. You have the unique capability to let multiple big data clusters run jobs directly against NFS or HDFS storage systems without moving the data. You can create as many big data clusters as are permitted by your resource allocation. Blue Data promotes a big data DevOps model for multiple distributions and products. Creating a cluster is as simple as a few clicks versus thousands of clicks in a typical physical deployment. Scaling out is also just a click away. Unique with Blue Data is the ability to provision and configure BI or search applications automatically with your Hadoop cluster. Blue Data auto-creates and configures Hadoop and Spark clusters consisting of Docker container nodes, including management consoles. No special wizards and skills required. You get a ready-to-use environment with your favorite BI or search tool with Hadoop or Spark under the hood. Run big data jobs and workflows using your existing clusters or on-demand transient clusters. Simply point at your data and run analytics in place. Visit us at bluedata.com for more details and download the Epic Lite version for free.
Hello, I'm Asa Eisenhart, and this video provides a short overview of how a Hadoop data analytics platform and an EMC Isilon cluster work together. To begin, let's look at three important distinctions about Isilon and Hadoop. First, unlike traditional Apache Hadoop platforms, Isilon clusters serve as the storage system for Hadoop data, separating it from compute resources. In a traditional setup, storage and compute systems are shared resources. The Hadoop Distributed File System, or HDFS, is used for data storage, and MapReduce and Yarn are used for computational analytics. The name node is a separate server that holds metadata for every file that is stored on the data node. Each file is copied 3 times for protection. Often, production data is stored in production environments and then copied to a landing zone server to be loaded onto HDFS. This process is network intensive and exposes the name node as a potential single point of failure. On an Isilon cluster, each node acts as both the name node and data node, providing automated failover protection. Data is protected using a Reed-Solomon algorithm for data striping, which provides more storage efficiency. No data migration is required. The second distinction is that HDFS is supported as a native protocol in the Isilon OneFS operating system, the same way that other protocols such as SMB and NFS are supported. Here's how it generally works. After you activate an EMC Isilon HDFS license and accept the license agreement, OneFS turns on the HDFS service. Write data directly to the Isilon cluster using NFS, SMB, HTTP, or FTP as you typically would. Spin up a Hadoop compute environment and connect to any node in an Isilon cluster via the HDFS protocol to read and analyze data. Lastly, you can use Isilon's enterprise file system features for Hadoop data security and protection. For example, OneFS controls access to Hadoop data through directory services, such as Active Directory or Kerberos authentication. Permissions can also be associated with directories and files to control access at the file system level. You can also create virtual regions on your Isilon cluster for Hadoop data using access zones. The access zone encapsulates a namespace, HDFS directory, directory services, and authentication. System connections can be isolated per zone for additional security. Finally, data is protected by snapshots, replication, and NDMP backup. Now that you understand the basics, the next step is to determine which Hadoop distribution you'll use. Isilon supports Hadoop distributions such as Cloudera, Pivotal, and Hortonworks. The distributions are installed in a compute cluster, and then the compute clients connect to the Isilon cluster over the HDFS protocol to access Hadoop data. Refer to the Hadoop Starter Kit for instructions on how to implement your chosen Hadoop distribution. For more information about Hadoop and Isilon, such as best practices and implementation considerations, see the Hadoop Info Hub on the EMC Community Network. Thanks for watching.